Hello, my name is Ping Yu. I'm from Intel. So I'd like to take this chance to introduce our work to enable TLS and apply TLS stack to Nginx and what we do and what we can share to you guys. And the agenda looks here some background for Nginx of TLS in kernel space. We have a team who we start to work on Nginx enabling, and we use our hardware to accelerate Nginx for a long time. So firstly, I'd like to introduce our experience, how we do it for kernel space. And then I'd like to share what we do, then switch to VPP user space. And then we can see what kind of story we can have. And based on TLS, we have two methods. One is the VCL implementation. Another one is LD preload mode. And we'd like to introduce how we do that. And currently, we still think that we are doing the functionality stuff, and we still need to focus more on the performance side. So we will also emphasize what the next step we will do. And yeah, so let's begin. For TLS, we know TLS comes everywhere, and the trend to use TLS is very obvious. And many people will start to deploy TLS-based solutions. And even some websites, such as Apple, stop to support non-TLS transportation. So it means that TLS is everywhere, and we need to emphasize more for enable TLS. And since TLS actually is a very heavy operation, and we know that when, especially for handshake, it needs both party to exchange the authentication and for the key, and then to get the handshake. So this is very difficult, and especially for the asymmetric part of the algorithm. And another thing is that as more people start to deploy TLS, and the TLS 1.3 also becomes one open stand to implement that. Based on that, many companies start to explore the possibility to use the hardware to do that. You can see that in the left part is for the software solution, and the right part is for the hardware part. And we can see that hardware part can help us to accelerate the TLS and by reduce the CPU usages, because CPU is very good resource for the workload. And same since that, for example, here we have QoT engine to help to offload all the crypto requests to the hardware, and then the hardware can get response for the algorithm, and then got it to be done. And if we want to do hardware, we can see that Intel provide quick system technology. Actually, I heard QoT from the previous two presentations already. From Hongjin, from Jill, they also mentioned that QoT can provide, and QoT actually can provide us a bulk crypto offload. It can help you for IPsec. So this work is, Jill also mentioned that. And for public key, and it can also help you to offload the public key authorization. It can help you to do the handshake. And also QoT can help you do the compression stuff. And we will work on that later. So if we do QoT, if we want hardware to offload your crypto stuff, so what kind of things we need to do is that we need to provide asynchronous mode, because this is very important to hardware offload. Because each time when you talk with hardware, you don't need to expect that it can return the result immediately. If you want to do that, if you want to waiting for the response, you need to spend much cycles to waiting for that. So the basic way is that you need to enable sync mode. It means that when you send out the request, for example here, you send out the request 1, 2, 3. You don't expect that it can return immediately. And then you will use some kind of polling to get response later, so that you can batch handle the request. So it can help us to maximize the performance for that. So when I do the QT accelerations, we will always enable async mode to maximize the performance and to make full use of the hardware to help you to get the maximum hardware spec. Yeah. So if we want to do that, so let's take it back to the kernel space. If we want to enable the async mode, it means that this is in the right side, it's the current unmodified Nginx. It just the Nginx workers will talk with the stacks, with the OpenSSL stack, and the OpenSSL stack also do two kinds of stuff. One is that to talk with the TCP IP stack, and another is that to talk with the OpenSSL part. So this is the kernel space part. And if we want to enable async mode, it means that we need to use a smart way to do that. And this way is that to make the application to talk with the hardware, because they need to async, they need to talk, they need to be communicated. And in this way, we need to add an extra model in the Nginx part as an async mode. And this async mode will be utilized to make the communication between the application Nginx to talk with the hardware part. And this is the async layer. It means that we have to do changes for the application. And even if we do, for example, currently we do that in Nginx already. And if we want to enable another application, it means that we have to enable another application, for example, Apache or a tree proxy to do similar stuff. And if we want to enable Envoy, we also need to do similar stuff. So it means that we are wondering that if we have a way to make it transparent and to make it, if we want to do one thing, we can enable all of the applications. So this is the reason we want to explore the possibility to do that in user space VPP part. And so we do that. And this is the basic story and how to apply a Nginx stack with the final VPP part. And I think besides the TLS problem, we also have other reasons to enable Nginx to enable the VPP part. One of the reasons is that the kernel scalability issues. If the throughput becomes very big, it means that the kernel space has some difficulties to scale. Because kernel space did not provide a very good way to pin some traffic to specific cores. And so by doing that, in the right side is a VPP daemon. And this daemon provides interface to with the shared memory. And the Nginx will talk with the VCL library, and this library will connect it to the VPP daemon, and it will be provided as a shared memory channel. And by this channel, it can talk with the VPP daemon, and then to provide the fivefold interface to got the read-write transparently. And also, Nginx can provide, because Nginx also needs to talk with the kernel space for the file operations. So this is the architecture, how Nginx can talk, how Nginx can use VPP to offload and to use the transportation based on the user space part. And so we just mentioned too much for TLS. So how to support TLS for that, based on that story. And this work is basically to put TLS in the transparent port of the VPP host stack. And we mentioned that TLS is also stand at the TCP layer. And also, TLS layer can be utilized as a transportation of the application. So TLS is currently like a way in the middle of the stack. So it can, as the application session, it likes transport to provide the TLS connections. And also, it will utilize the TCP layer to get the full stack support for the transport support. And in the middle, we also do some async enabling to QAT. It means that when it sends out the request to hardware, it will enable async mode. So all of the work we previously did in Nginx part, we will move that work in the TLS async mode in VPP part. And by this work, we also trying to talk with the OpenSSL master branch to enable a feature, because in the past, OpenSSL just provide kernel space-based solution with the application to talk with the engine by an event FD. And this event FD is not very efficient way to enable the data plane transportation. So we work with the OpenSSL community to provide a user space-based solutions to make the application to talk with the engine transparently by impose some new APIs, such as the set async callback and set async get async status, so that the VPP can use a callback mechanism to get everything from the hardware without any interactions for the kernel. So by this way, we can obviously improve our performance, and also we can provide this kernel bypass solutions so that we don't need anything to talk with the hardware part. And based on that solutions, so we can also propose the Nginx enabling based on VPP host stack by LD preload. And unlike the VCL solutions, LD preload is also a more transparent way to provide the TLS support without any changes, without any one-line changes in Nginx. We just do that. And what we do is that we can use LD preload to make all the system call of the such as socket, read, write, come to LD preload, come to VCL preload .so. And this binary can provide two-way functions. One is that when it realizes that this is a network transportation, it will go to the VCL library to connect it to the VPP daemon, and then to get the transportation from the VPP daemon. And if this is a traditional socket interface, or such as Unix socket, or such as the file operations, it will still go to the kernel space. So this is the LD preload work mode. And the VCL library also need to talk with the VPP daemon and got the shared memory to get the interface, so that it can construct a FIFO connected to the VPP daemon. And the VPP daemon serves like a layer for all the transportations for both TLS and for TCP connections. So here, and all of the things will just hijack the Nginx socket interface. It means that even if the Nginx is doing the TLS work, but from the perspective of Nginx itself, it just thinks that it's just using the TCP connections. So this is the work we do. And by that way, even if we enable the TLS, and Nginx does not understand that, and Nginx just thinks that it is just using the traditional TCP connections. So we will not use the TLS implementation on the Nginx part. We just use the transportation enabled for traditional TCP connections in Nginx. Yeah. And to do that, we need to do something for that. And based on that, we have designed a new interface for VCL to provide TLS operations. So this interface is just like socket interface. So traditional socket interface just can allow you to provide your protocols. But this protocols is just like TCP, UDP. It will not include TLS. So we will enhance that, and we will read some environment variables. It will make the detailed implementation of the TCP with the socket is based on TLS instead of TCP connections. And another thing is that, as I mentioned, Nginx just think that he is using the TCP connections to talk with the peers. So Nginx does not have any knowledge of TLS currently. So by this way, we also need to provide some TCP transportations provided to Nginx so that Nginx understand actually it is using the transport based on TCP part. And the detailed implementations is like this. For VCL enabling of TLS, besides traditional TCP and UDP, and we added TLS protocols, and it can be provided, and this protocol interface can be provided to VPP session create. And another thing is that everybody knows for TLS, it needs a certification and also need to provide the key. So also we provided interface to help you to provide your certification and your key by VPP.com session TLS add set and TLS add key. And as we also provide new environment variables. And these variables is to tell Nginx and, that it's using a transparent TLS. And LDP transparent TLS is an indication. If you enable this environment variables in the implementation, and the LD preload will assume that you will use the transparent TLS interface. So it will not just provide the traditional TCP protocols to the VPP session create. Instead, it will provide the TLS of the protocol to tell VCL that we are not using TCP, we are using the TLS. And then when it realizes that it will TLS, so it means that it also need to provide the certification file and your certification and the key file. So LD preload will smartly read that file you provided through the environment variables, and then it will provide, and then this file and the certification will be passed through the shared memory to the VPP daemon, and the VPP daemon will based on these certifications to set up connections with the peer outside. So this is the basic way we can do that. And this code is also enabled already in the VPP master branch. And another thing, as I mentioned, is that when TLS is accepted from VPP daemon, TLS is a transport part. But this transport is based on TLS. It does not provide any information for TCP information. So based on that, we also need to implement a TLS endpoint. This, just like this picture shows, the session layer is actually talking with TLS. And TLS is to rely on the TCP layer. And our interface is to provide, based on the session part, it can use the dash line to provide the get transport endpoint. So by implement that interface, it can help you to link the TLS with the underlying TCP transportation for remote IP and port. And it can also provide listen endpoint, because listen point is not get from the transportation. Listen point is get from the local IP port. So by implement this endpoint part, it can sometimes some kind of cheat Nginx to for the TLS and to get the transportation for that. Yeah. And then based on this implementation, VCL layer can transparently link the TLS with the TCP part. And one more thing is that Quick in VPP implementation also using a similar way to go to this interface. Yeah. So this is current work we do, and as I mentioned, that this is mostly currently for functionality work, and functionality is okay. And we also realize that when enable VCL based on Nginx, and we also realize that there's some performance currently is not tuned very well. So next step is that we'd like to work together to tune the performance. based on VCL layer and based on the LD preload. And also, when this transportation is become stable, and we also continue to tune the performance for the TLS offload for Nginx, so that we can use traditional way to connect to Nginx, and then use the user space library, and to tune how much we can improve to that. Yeah. And finally, Nginx is one of the example to demonstrate that we can provide transparent TLS. And we also want to do is that we can support more applications, just like using this library, using this mechanism to provide more application support. Yeah. So basically, this is our work next stage. And the key takeaway is that Qt hardware continues to provide a unique value in cloud native for hardware accelerations, especially for TLS accelerations. And then in VPP hot stack, it provides TLS transparent design so that it can just use, it can hide the TLS inside the stack. So this is, I think, this is a breakthrough innovation for that. So we don't need to implement every TLS in the applications. So it will make things very clear. And we also enable the TLS stack based on LD preload and the VCL mode in VPP. And basically, all of the code is merged to the VPP master branch. And next step is the performance tuning. Yeah. So thanks, you guys.